Hello class, so in this video we are going to go over how to graph the trigonometric functions. Last time we learned how to evaluate them, now we're going to graph them. Alright, so this is what a table would have looked like from last time. Right now we're going to use this. I'm only going to use up till pi, but you're going to be able to go until 2 pi anyway. We're just going to go up to pi first so that we can see a little bit of what's going on and then derive the rest of the patterns from there. So the first one we're going to work with is the sine function and the cosecant function together because they're reciprocals, right? So here I have derived, or converted, all of the values into decimals just because it's easier to graph decimals. So I'm going to color code these. Sine is going to be blue and the cosecant will be red. So let's start graphing sine. At 0, it is 0. At pi over 2, it is 1. So notice I'm just doing that. And then at pi, it is 0. If you recall, at 3 pi over 2, it'll be -1, and then 0 again. So the same pattern is going to continue on like this. Right now, it might be tempting to just draw a line and a line and a line. This would be called wrong, because if we look at the details of this, at pi over 4, which is over here, we have 0.707, which is like around here-ish. So you can already kind of see that's going to be a bit more curved. If you use the rest of the points, you'll actually see the curve itself. I'm going to get rid of the axis later on so we can see the curve better. But essentially, you'll get this. Make sure that it's curved, but not too curved. And make sure it's not pointed either, but make sure it's, I guess, pointed looking enough so that you can tell that it's not just going to be like a big circle. It's not a circle, but it's not a mountain like that. It's like kind of a mix between them. It's like the best of both worlds. Alright. So then you can just continue that on forever. It will do this until the end of time. So if I were to actually get rid of the axis, you would see that we get essentially that. Actually, that looks a little bit better without the... I'll just do that from now, actually. Yay, improv. Alright, so cosecant. It is undefined when sine is 0. So when sine is 0, cosecant is going to be undefined. So at all those x-intercepts, I'm going to draw vertical asymptotes. Oops. Sorry. So something like that. Alright. So now when sine is 1, it is also 1. And if you do recall, when sine is -1, so is this. So you're actually going to see this going on. And then essentially what's going to happen is this thing just goes toward the asymptote. So if you graph sine, you can graph cosecant pretty easily on the same axis. The main thing is just making it look correct. Also, don't call these parabolas because they're not parabolas. They're just U-shapes, I guess you can call them. But yeah, so that's what those two look like together. Very similar thing is going to happen with cosine, because remember the cosine is just sine shifted over a little. So let's look at that. You can pause the video if you need to take a picture, copy this down, etc. But I'm going to change the thing right now. Okay, so again, I'm going to color code so that it's a bit easier to see what's what. At 0, we got cosine equals 1. And then pi over 2 is 0. And then -1, 0, 2, and exact same pattern is going to continue on the other direction. And very similarly, you'll also notice that you get this squiggly line thingy going on. Just gonna make it look nice-ish. That's pretty bad, actually. It's a little bit easier if you have a bigger graph, because then you can kind of see the details of what's going on. I mean, just like to draw it. That's why I'm struggling a little bit, but it works. Alright, oops. Alright, so that is the cosine graph. Again, similarly, notice that at the zeros, x-intercepts are going to have these asymptotes going on. So you can draw those there. And then just do the exact same thing that we did with cosecant. Because at the ones and the negative ones, they're going to intersect. And just go opposite directions like this. So secant is just going to start going toward the asymptotes. And then start at those exact same 1 values. And then that's what that's going to look like. Oh, forgot. Okay, so if you need to pause the video, do that. I'm going to change to the next one right now. Okay, last ones. So again, color coding. And for this one, I'm actually going to do them both. Oops, wrong color. On different layers, and I'll just show you them separately and together at the same time, because sometimes when they're together, things get weird. Or just, it's kind of hard to see. So, the pi over 2's are going to be undefined for tangent, so let's just make those asymptotes first. So blue is going to be tangent. And then we'll see some nice things happening. Alright, so at 0 it's 0, at pi it's 0, at negative pi it's 0, at 2 pi it's 0, at negative 2 pi is 0, all the whole pi's are 0. And then we'll get this thing going on. And this is going to go on like this forever and ever and ever. So make sure you draw this correctly. There are correct and incorrect ways to draw it. So make sure that the function pieces are not like crashing into the asymptotes. Don't make them oddly like this. Like I've seen that before. That's not correct, nor is it even a function, because it epically fails the vertical line test. But yeah, so this is what tangent looks like. Now I'm going to get rid of that so that we can see cotangent. So if you need to take a picture or copy this down, just pause the video. Getting rid of it right now. Alright, let's look at cotangent then. It does exactly the opposite in terms of the asymptotes. Now it's at the 0 points and the whole pi points. And then its zeros are going to be in between at the pi over 2's. And then you're just going to go in the other direction this way. So it's going to be a forever decreasing function like this. So if we compare them to, that's a little bit why I decided to not do them together, because people like to draw them like chromosomes, like this. That is wrong, because they don't do that. They don't intersect at the same points for their zeros. They do for other things. It doesn't actually make any sense for them to intersect at their zeros because the other function is going to be undefined at the 0. Alright, so this is what they all look like together. So again, pause the video if you need to. But yeah, this is basically it. In future videos, we're going to talk about how to evaluate the inverses and work with the inverses as well.